Today we're building one of the most aggressive distortion circuits ever made, the ProCo RAT, from schematic to working breadboard. The RAT is a high-gain op-amp distortion, one op-amp stage, hard clipping diodes to ground, and a filter that shapes the top end. The entire tone lives in the feedback network and those two diodes. The first thing that we're gonna do is work on this blue section, the power supply. So let's hop right into it. The first thing that I like to do is connect both of my power and ground rails. So I'm gonna go ahead and do that right now. And now that we have that out of the way, we can start working on our schematic. So we have just a couple components going on in the power supply. First one, I'm gonna grab the resistor and the D3 diode. So we have our 47 ohm resistor, and I'm just gonna place that anywhere in our power rail, just like this. And then I'm gonna grab the diode and I'm gonna put it from the power rail to ground rail, making sure that the little line on the diode is in the power rail. And it doesn't really matter where you put these in the power or ground. The next thing I'm going to grab is the 100 UF electrolytic cap and the 0.1 capacitor, both going to ground. With these electrolytic caps, they are polarized, which means there is a positive and negative leg. The positive leg is always the long one and the negative leg is the short one. So in this case, the positive leg is in the 9-volt power and the negative leg goes to ground. And then same thing with the 0.1 UF cap. Just like that. And this is what we have so far. The next thing that we're going to do is we're going to hook up our voltage divider using the two resistors and the capacitor to ground. And what that's going to do is give us a 4.5 volt virtual ground, which we're going to use for the op amp. And I'll show you how to do that right now. I'm going to take our first resistor and it's going to come out of the ground and I'm going to put it into one of the rows on the breadboard. I'm going to grab the other resistor and I'm going to put it in the power rail and I'm going to drop it into that same row as the first resistor. Finally, I'm going to grab the electrolytic capacitor, and again, it is polarized, so the positive leg is longer than the negative leg. So just making sure that the short leg ends up in ground. And this is what the voltage divider should look like. All three of those component legs should be in the same row. One resistor is going to ground, the other resistor is hooked up to the 9-volt power, and the capacitor is going to ground as well. And now I'm going to show what that virtual ground looks like on my multimeter. As you can see, we have about 4.5 volts, which is the 9-volt power cut in half, and that is exactly what we're looking for this circuit. All right, so that is the power supply part of this schematic already finished. This is what you should have if you're following along. Really not too much going on, so without any delay, let's hop into the clipping stage. All right, so we already made it to the clipping stage of the schematic, and we're gonna start with the guitar input and work our way to the right. So I'm gonna add my guitar input right here and drop it into one of the rows on the breadboard, just like this. Doesn't matter where. So this is now my guitar input. And now what I'm gonna do is grab a 1 meg resistor and I'm gonna go to ground, coming off of that guitar input. So it's in the same row. And then I'm gonna grab a 22 NF capacitor and I'm gonna connect it in the same row as those, the resistor and the guitar input as well. So as you can see, we've made those first 3 connections. And next we're gonna connect the 4.5 volt virtual ground to a 1 meg resistor, and then a 1K resistor, and then a 1 NF cap to ground. So let's do that right now. I'm gonna grab the 1 meg resistor and I'm gonna add it to the other leg of the cap, just like that. And then I have these nice jumpers that I'm gonna use to jump from the 4.5 volt reference to the other leg of my resistor. So 4.5 volts, resistor, other leg is touching that cap, just like in the schematic. And then finally, I'm gonna grab the 1K resistor coming out of this cap, and I'm just gonna drop it into a new row where there's nothing above it, so it's just by itself. And then I'm gonna grab my 1 NF cap, put it in that new row, and I'm gonna go straight to ground, making sure that it ends up in the same row as this leg of the resistor. So that is what the input should look like. Fairly simple. Just double checking that all of our legs are touching the other components that they should be. That all looks good for now. And then the next thing that we're gonna do is drop our op amp into our breadboard. This is the op amp that we're gonna be using, and I'm gonna place it so it is going in between this kind of split in the breadboard. It's gonna look something just like this. There we go. It can be a little tricky to put in there, so just be careful. So now we have our op amp placed in our breadboard, and I'm gonna go ahead and take care of pins number 7 and 4. 7 being the 9 volt reference and 4 being to ground. So those should be super simple to take care of right now. So like the schematic said, pin 7, which is this pin right here, and it's a little bit tricky to see, is going to be going to the 9 volt power rail. And then pin number 4 is going to ground. Just like that. So here's a little bit of a better look. So pin 4 is going to ground, and pin 7 is connected to the 9 volt power. The next thing that we're gonna do, which is fairly simple, is connect capacitor 3, the 30 PF, between pins 1 and 8. So here's my very little ceramic 30 PF cap. That's kind of hard to see, but I'm gonna put it in between pins 1 and 8. And I'm really stretching the legs of this little cap. But it's gonna look something just like that. So the legs 1 and 8, and the cap just touches both of those pins. Moving right along, we're gonna go from pin number 6 into our distortion pot, and that is connected to lug number 3. And then additionally, pin number 2 on the op amp is connected to lug number 2 on the distortion pot. So I'll show you what that looks like now. So like I said, pin number 6 goes into lug number 3 on the distortion pot, just like that. And then pin number 2 goes into lug number 2 on the distortion pot. So let's see if I can get it over there. All right, so now I have pin number 2 connected to lug 2 on my distortion pot. And now we need to add C4, the 100 PF capacitor, in between lug 3 and lug 2 of our distortion pot. And that is fairly simple. We just take our little ceramic cap and we just place it right in between those two lugs. So one leg of the cap is on lug 3, the other leg of the cap is on lug number 2. We're getting close to the end of the clipping stage now. Hopefully you're following along. Next, we're gonna go and take care of this tone circuit that is attached to the distortion pot. And this is really where the RAT gets its signature distortion tone from. So we have two resistors in parallel, the 47 ohm and the 560 ohm, connected to the 2.2 UF cap. and the 4.7 UF cap both going to ground, and I'll show you how to hook that up right now. Starting with the 47 ohm resistor, I'm connecting from lug 2 of the potentiometer. And then I'm taking the 2.2 UF cap going to ground. And then I'm taking the 560 ohm resistor, again plugging one leg into lug 2 of the distortion potentiometer, and then coming off of that leg going into ground is the 4.7 UF capacitor. So it should look something like this. All right, very close to the end of the clipping stage now. We just have to add the 4.7 UF cap, the 1K resistor, and then those 2 clipping diodes. So coming out of pin 6, I'm going to take my electrolytic cap, and I'm plugging the positive side into pin 6, and then I'm dropping the negative side into a new row where there isn't any existing connections. Then I'm taking my 1K resistor and I'm putting it in that new row, and then dropping the other leg into a new row as well. All right, last thing we need to do for the clipping stage is add our clipping diodes. So if we look at our schematic again, we can see that the diodes are going in opposite directions, which means that it is going to be symmetrical hard clipping. So I'll show you what that looks like on the breadboard. These tiny little diodes have little black bands on the tip of one side, and we just want to make sure that those are going in opposite directions. So one of the black tips is going to be going into ground, and then the other one should be in the opposite direction. So the side without the black tip should be going to ground. And both of those legs are plugged into the same row as that 1K resistor. And then both of the legs of the diodes are going to ground. And I just realized I plugged these in the same direction. So I had those diodes going in the same direction. I just flipped them around really quick. So we can see that both of the diodes are touching that 1K resistor and then going into ground. And with that, that concludes the clipping stage. All we have left is the tone control and the output stage. All right, moving on to the tone control next. This is going to be a very quick section. There's only 2 components, so let's move swiftly along. Coming out of those 2 clipping diodes, we're going to go into lug number 2 of our tone pot. So connecting to where those clipping diodes touch the 1K resistor, I'm going to go straight into lug number 2 of our potentiometer, just like that. And then out of lug number 3, I'm going to go from a 1K or 1.5K resistor, drop that leg into a new row, and then I'm going to grab a 3.3 NF cap, putting one leg in that new row and the other leg straight to ground. It's going to look something just like that. And the last thing I'm going to do for this section is add our 22 NF cap. And I'm going to put that in that new row where these 2 components were already touching. I'm going to drop that leg into a new row. So that's the tone section complete. All we have left to do is the output stage, and we can finally try the RAT. If you're still following along, I just want to give you a quick applause. We're nearly there. The next thing that we're going to have to do is the output stage, and we're going to start with a 1 meg ohm resistor to ground coming off of that 22 NF cap that we put in the last section. And that's going to go just straight to ground, just like so. So this resistor is touching the right leg of the cap, just like that. And then we're going to go into our transistor. In the schematic, it calls for the 2N545F or 58, and that's what I'm using. And we want to plug the gate leg of our transistor, which in this case is our leftmost leg, and then we want it to be touching that cap and that resistor that we just put down. So that leftmost leg of the transistor is touching the 22 NF cap and that 1 meg resistor to ground. Hopefully you're able to see that. The next thing that we're going to do is we're going to go 9 volts to the drain, which is the rightmost leg of the transistor, and that's easy enough with a jumper cable. Just like that. So 9 volts straight to the rightmost leg of the transistor. And then from the source, we're going to go 10K ohm resistor to ground. So that is the middle leg of the transistor. And I'm going to plug that straight into ground, just like that. And then finally, I'm going to use my 1UF cap, and I'm going to go from the source, which is the middle leg, positive leg, and then the negative leg, I'm just going to drop into a new row. And then where I put that leg in that new row, that is going to act as our effect output. So using my handy jumper cable again, I'm going to take this, plug it into that negative leg of the cap that I just dropped into the board. And I'm going to take this and go all the way over to our volume control pot. I'm going to plug it into lug number 3. So looking at the schematic, we just did 1 UF cap, and I just plugged it into lug number 3 of our volume control pot. And then based on the schematic, lug number 2 is our output. And then finally, lug number 1 is going to be going to ground for our volume pot. So that is the entire circuit on the breadboard. I'm gonna go test this really quick and make sure that it works. If anything is wrong, I'll come back and show you exactly what it was and how to fix it. All right, so I just got back from testing it and I realized I made a really silly mistake. I never connected our input from the guitar into the op amp. So all that was connecting this additional jumper into pin 3 of the op amp. And after that, everything worked perfect. So now let's go hear some tones.